Okay, well, a lot going on in this one. We have multiply and divide. So let's leave the multiply. We have x squared minus 9 over x squared minus 1. All of that times two trinomials here, x squared plus 2x plus 1 divided by 2x squared plus 9x plus 9. All of that divided by another rational expression, 2x plus 3 over 1 minus x. All right, well, first things first, let's get rid of that division by multiplying by the reciprocal of this last term here. So when we do that, that brings this whole expression to x squared minus 9 over x squared minus 1 times x squared plus 2x plus 1 over, I'm just copying things back down, 2x squared plus 9x plus 9, all times, now we're multiplying by the reciprocal. So now it's 1 minus x divided by 2x plus 3. Okay, let's get busy with some factoring. Let's see, we have a difference of squares here. So let's pull up that formula. If you recall, the difference of squares is that one there. So a squared minus b squared is a plus b, a minus b. That's going to apply twice here. That's going to apply to both this one and this one. So let's use that. So we have x plus 3, x minus 3. And down here we have x plus 1, x minus 1. Okay, and this first trinomial on the top here, if you look at those, notice we have a perfect square in the first term and the last term. So we could spend time factoring it, that's fine. But notice that this is actually a perfect square trinomial, so we use our perfect square trinomial expression right there. Okay, so using this formula gives us x plus 1 squared. Okay, or you could sit around and factor it. Up to you, no problem. The formulas are made or are there to make things easier for us. So it's not like, oh, the formulas make it harder. No, the formulas actually make it easier. So I recommend using them, but some people just like to factor everything. That's fine too. To factor this second trinomial, we'll use the diamond method. All right, so there's our x, and let's see here. This is 2 is our a, 9 is our b, and the other 9 is our c. And remember that ac goes up here, b goes here, and then we have an ax over here and an ax on the right. Okay, so ac, a times c is 2 times 9, so that's 18 there, and b is 9. And then here we'll just put our ax, well, a is 2, so we have 2x and 2x. 2x and 2x, and we put our division line in there. Okay, so we need factors of 18 that add to 9. It's always factors of the top one that add to the bottom one. Okay, well, 1 and 18 doesn't do it. 2 and 9, 2 plus 9 doesn't get to 9. How about 3 and 6? 3 times 6 is 18, but 3 plus 6 is 9. So that is the one we want. So here we go, 3 and 6. Cancel these out here. The 2 and the 6 cancel, leaving a 3. So this is really x over 3. And here we can read it off like that from top down. That tells us our factored form. So let's just go ahead and squeeze that in right beneath this trinomial. All right, so we have 2x plus 3 and x plus 3. Okay, you could have also used trial and error for that one. All right, so here, well, I'm just going to rewrite this 2x plus 3 to be consistent. That's still hanging out. For this 1 minus x term up here, this is in factored form. I admit that. But look, we have this x minus 1 down here that would really be fun to cancel out. So they're so close. We want to get these to be the same. So look what we can do here. I'm just going to go up here with it. We have 1 minus x. I'm going to factor out a negative 1. Look what happens. When you factor out a negative 1, that changes the sign of everything left behind. So we have negative 1 plus x, which then we rearrange, and that gives us negative 1 times x minus 1. So this 1 minus x term can be rearranged to get -1 times x minus 1 here. Okay, let's go ahead and start in with the canceling here. Okay, so I'm seeing an x plus 3 and an x plus 3. What else can we get? Well, we have x plus 1 down here and 2 of them up here, so I'm just going to cancel one of them. X minus 1, x minus 1, that's what we worked so hard for. Okay, let's clean it up and see what we're left with. We have this -1 still hanging out. I'm just going to bring that all the way to the front. Okay, we have an x minus 3 left over. And we have an x plus 1 because we only canceled the squared part. So we have a single x plus 1 still hanging around. Okay. In the denominator, we have a 2x plus 3 and a 2x plus 3. So I'm going to write that as 2x plus 3 squared. Okay, I'm going to give it a quick look over, make sure nothing else cancels. I'm not seeing anything. So there's the final answer.